Thank you to the organizers. It's nice that you put together such a focused session on crowded analyst coverage. I want to point out that we're going to be talking about crowds in kind of a different context. We're going to be talking about crowds, crowdedness in the sense of geographic clustering. And so that's kind of our take on this, and it's going to be a more empirical look. We often think of crowds as being useful. There we go. So we often think of crowds as generating better forecasts than any of the individuals in the crowds, and we've seen this in a lot of different contexts. The weight of a steer at a county fair by a bunch of farmers, or internal prediction markets, these types of things. The question we're asking is about crowds of analysts and their ability to make these consensus estimates and how well they perform. And one kind of subtle point of the wisdom of the crowds is one key aspect for a crowd to be wise is that crowds have to have essentially a diversity of opinion. There's got to be independence in the way that the participants in the crowd are coming up with their forecasts for this wisdom of crowd effect to take over. When we look at analysts, it turns out that there's massive geographic clustering of analysts. We often think of analysts as being on Wall Street. You'll hear that phrase a lot. It turns out about half of analysts either work on or near Wall Street in the New York metropolitan area. But that also means that other analysts are geographically dispersed across the entire country. If you look at this kind of plot, you can see that there's a number of brokerage houses and a number of large US metropolitan areas. So that means there's kind of geographic spread in where the analysts are covering the same firm from. And so the reason why this might be important is that analysts use a variety of information to come up with their forecast. Much of the information that they use is widely disseminated. We think of information that comes from Edgar or annual reports or conference calls. This information is spread out to analysts across the entire US and around the world pretty commonly here. Can you still see the screen? No. Mikhail?
No. Mikhail, can you turn on the screen share again?
Well, I'll just continue until we get this technical issue fixed. But essentially, analysts, some of this information is spread out across the entire U.S. But analysts frequently make it a point to say, "Hey, I do a lot of primary research. I get into stores, I buy the products, I go and see what are the store's shelf stock, which products are humming, are the checkout registers flying." Peter Lynch, we have this quote here that said, visiting stores and is one of the most critical elements of an analyst's job. And so there's information that's kind of more local in nature to the analyst. And it makes sense that, analysts use some of this local information in addition to this kind of information that's available to everyone. One potential issue with this is that the information that's available to just the analyst, it's hard to them, for analysts to know whether they can kind of trust this information, whether this information is essentially the truth, or is this just kind of their local realization of how busy stores are across the US. And this is kind of a general human problem. Tversky and Kahneman have this idea that individuals also fall victim to this hasty generalization bias, where they generalize from small amounts of personal information. They assume that this is how the greater distribution looks. And so in this setting, you might be concerned that an analyst who goes to their local, say, Home Depot, and sees a full parking lot, assumes that this is how parking lots and Home Depots across the United States look. Inherent in testing these ideas about whether or not professionals engage in things like hasty generalization is it's really hard to kind of do tests for this for an empiricist outside the laboratory setting, because almost by default, information that is kind of local only to a small subset of people is inherently hard to observe for the empiricist usually. Or you can do it in a lab setting and assign local information to people, but then we have the concerns of that the lab setting might not generalize. So what we're going to do is we're going to take advantage of some really nice data that allow us to observe the information that's local to a subset of decision makers, these analysts, and yet it's not available globally to all people at that point in time. So our research question is going to have two main thrusts. First, we're going to look at this at the individual level. First, do financial analysts of retail firms make these hasty generalizations based on their own local information? And then we're going to say, what is the implication of the fact that sometimes the stock might be covered by analysts who are all clustered in one geographic area, and so they'll have the same types of local realizations, and thus the wisdoms of the crowd effect might be taking over, versus other firms that have more wide geographic coverage where kind of this wisdoms of crowds effects might drive the consensus to be more accurate. So what we're going to observe is that retail analysts that are covering retail stocks, shade their earning forecast towards the locally observed parking lot counts. So a retail analyst covering, say, Home Depot in Atlanta, and sales are really big in Atlanta, that analyst will be more favorable than other analysts covering that same stock at the same point in time. The other thing that we're going to look at is what is the implication of this geographic diversity? And we're going to find that the consensus forecast errors are going to be larger when analysts are more concentrated in a small number of MSAs. And this result's going to hold even if we look at just for the same number of analysts. So you take the same number of analysts, concentrate them in one spot, compared to another firm that same number of analysts is spread out over more MSAs. The one with more concentrated analyst coverage is going to see larger consensus forecast errors. Obviously, the big empirical challenge I've already alluded to is how do you identify and observe this geographically diverse local information? Our answer to this of course, the answer is always heliocentric satellite imagery. So, this is a perfect time to get on the Slack channel and ask Marcus some good questions about exactly how the satellites work and such. But essentially, all we're going to do is we're going to take advantage of this company, Orbital Insight. Orbital Insight actually doesn't have any satellites of its own. It buys up satellite imagery from a bunch of these satellites that are already in place. And then they use machine learning algorithms to process these images to find car counts on these maps. And so on the right, we see an image of some parking lots. Orbital Insight's value add in this setting is to go ahead and kind of put maps down, use these complicated kind of imagery techniques to figure out car counts in these parking lots, assign them to stores. So in this image, we see a Kmart, a Home Depot, and a Costco. They've done this. They started their image processing in 2009. We're going to use data through 2015. During this period, Orbital Insights and their big competitor had not been widely selling this image data. In fact, for the first couple of years, they bought up old photographs for their machine learning algorithm. So Orbital Insight doesn't even exist in the earliest years in our sample. So it's not like this data was available to anybody in most of our sample period, and we'll talk about the implications for that. One thing that's why Orbital Insight exists is it turns out that satellite image data of car counts is highly useful for predicting firm performance. There's a couple recent studies, one by my co-author, that show that car counts in aggregate across the entire US help predict firm performance. What we're going to note is at the local level, after figuring out how much of the local signal is correlated with the national signal, that the local measures are basically a noise. And so we're going to focus on kind of that noisy aspect throughout. So it does make sense for analysts to use local car counts. They're a good signal of the national levels. The problem is the analyst doesn't really know how much that local signal contains a little bit of noise that isn't reflected in the national averages at that point in time because this data is not available to them. All right. And so the other piece that we need location on the financial analyst. We do this through a series of FOIA requests to states. We're able to go ahead and get detailed data about where all the financial analysts are located, their office locations. So we're able to say, for most brokerage firms, they'll be at one location, but for some brokerages, particularly in certain industries, it's common that maybe they'll have an energy group down in Houston or something like that, even for a Wall Street-based firm. Other firms are kind of located in one or two different geographic regions. So our main measure that we're going to be using throughout here is what we're going to call a car count difference. And it's how much the local car count in an MSA exceeds the national car count scaled by the national car count. And so these car counts are going to be how crowded the parking lots are. And essentially this measure, car count difference, will be essentially each MSA's kind of idiosyncratic, either kind of overweight or kind of underweight relative to the national average for that same firm at that same point in time. So we'll be able to watch not just across within the same firm in the same quarter, but we're going to be able to watch this over time because we're going to have kind of repeated snapshots from the satellites. So what does Home Depot look like from space? Home Depot, in the early part of our sample, is covered by just under a dozen firms, I believe. A lot of them are concentrated or located in New York, but we have Piper up in Minneapolis. We have Raymond James down in Tampa. And so there's some geographic spread. So let's hone in on Keith Hughes down here at SunTrust Robinson's Humphreys in Atlanta. It's in the Atlanta Financial Center. It's that big black building on 400, if you're familiar with Atlanta. And so for Keith, he's got a number of Home Depots that are nearby his office. And what we're able to do is we're able to look at what are the car counts on the nearby Home Depots and compare that, the local car count measurement relative to kind of car counts across in other locales. Orbital Insights does do some adjustments for store size and different types of store. If you think about something like a Walmart where there's a regular Walmart and a super Walmart, Orbital Insights does some adjustments for this. We use Orbital Insights adjustments to account for this. And so we have kind of a relative measure of how these stores are doing compared to their peers across the US. Importantly, we can start to look at how these stores do over time. So for Keith Hughes, we see as 2014 progresses, Atlanta is still exceeding much of the rest of the nation. But importantly, we can go out and zoom out from Keith Hughes here in Atlanta and go look at Peter Keith here at Piper Jaffray's up in Minneapolis and notice the stores are not doing as well up here in Minneapolis in Q2 2015. And this is actually kind of similar for a couple other of the financialists. Eric Bosshard over here at Cleveland has local store counts that are a little bit down. And then if we go down to Tampa, looks like Tampa is actually doing all right. So we looked at Raymond James analysts covering them, and stores are doing well. So importantly, we have kind of the bird's eye view looking down on all the analysts. So how does this relate to what Keith Hughes sees? We can see for Keith Hughes, essentially, he gets a signal about how his stores are doing. We look at the relative kind of strength of those. And of course, and I hope you guys expect, is in our cherry-picked example, it looks great, right? So as store counts go up, his relative forecast relative to his peers goes up. As the local store counts go down, the forecasts go down. Of course, we need to do this a bit more rigorously, so we are going to put this in a regression framework here. And so we're just going to put in on the left side the analyst error, their forecast error minus the actual, and then we're going to regress that on the car count difference. We're going to control for a host of analyst attributes, but most importantly, we're going to do a series of fixed effects that will rule out kind of the most plausible or concerning confounding effects. Firm quarter means we're going to look at the variation within the firm quarter, so Home Depot Q2. And then we're also going to do things like we're going to put in effects for analysts by firm. So maybe a firm is local. There's been a literature that shows local analysts do better. These analyst firm effects will control for those confounding variation. We'll even look at a analyst quarter fixed effect. So control for everything that's going on in the Atlanta MSA in Q2. So maybe the Braves are doing well, or it's sunny, and all firms are doing well. Even with these finer grain fixed effects, we see as the store's local performance is better, the analyst has a higher prediction here. So analysts shade in the same direction as the local information, and the size of the effects are similar to kind of other studies like Hong and Kasparek. Losing an analyst, wider dispersion, you see larger effects. We see larger, this effect is dominated among younger analysts, and it's also more common when there's less other analysts. So if there's more analysts that in more geographic diverse places, we see the analyst does not weight their own local information so heavily. I also want to go and say, hey, what happens when we zoom this out to the broader sample? So we say, why do brokerage firms allow this? Why don't brokerage firms spread out everywhere? There's a lot of I/O reasons why firms want to be up on Wall Street, and analysts typically cover one company. So there are frictions that keep them there. But what happens at the consensus? Do we see these effects manifest? And the quick answer is yes. This is exactly what we see. So we can look at this a couple different ways. One thing that we can do is we can just look at a simple summary stat and show when you have more analysts from more different or more MSAs covered, the forecast error goes down in just a simple univariate set. We can also do kind of a more rigorous regression approach, and we show as the Herfindahl index of concentration of analysts increases, we see higher consensus error. We can also see this kind of in the sense of as you increase the number of MSAs, consensus error goes down. We can take advantage of brokerage closures and compare brokerage closures where you reduce an analyst, but it's one of where there's multiple analysts from that MSA. So one of the, say the New York analyst goes away, so you see a loss of an analyst. You can compare that to a similar firm where they lose an analyst, but it loses one of the analysts from a MSA where there's only one analyst, so you reduce the diversity of the analyst coverage, and you can see that in those cases where analyst diversity is lost, you see an increase of consensus forecast error. So that's suggestive that it's the diversity that's driving this effect, and it's not some confounding variation. I think this is a kind of a nice graph in that we show that consensus error, even controlling for the number of analysts, decreases as you cover the stock from this, from more and more different MSAs. Again, consistent with this idea that when you have geographically dispersed analysts, their forecast errors are going to net out in the way that the wisdom of the crowds type approach would think. Finally, we can do some kind of within test here, and we find that this geographic dispersion effect is larger when sales are more observable. So we find larger effect in the retail industry, smaller effects in industries that maybe in-store visits might not be as beneficial for. We also see that this is more important in the post-Reg FD era, where there's maybe less inside information being given from firms. And importantly, we see that once the satellite data is available to the public for a particular firm, we see a reduction in this. And so when analysts can go and buy this car count data, we see that the kind of weight that analysts have on their own local information goes down. So again, this is all consistent with this idea that analysts are kind of using this local information. When it becomes public, they lean more on the public information. So in conclusion, we find two big findings. One, analyze generalize based on the salient local information. Analysts weight their local car count information, and then this effect manifests itself at the aggregate level. When a firm is covered by a more diverse set of analysts, we see lower forecast error. And you know, this is not a new finding. It goes back to an ancient Indian proverb about a wise man and an elephant. And you know, that if you have everybody touching from one side, we might, you know, all grab the elephant's trunk and think this is a snake. But instead, if we all touch the elephant, the blind men all touch the elephant from different pieces, you know, they think that it's different things. And at least they make different errors. And in consensus, we get a better measure than if we all make the same errors. So I think I'm about out of time here, but thank you very much. And I look forward to all the feedback from the discussant and the crowd.
Thanks a lot, Will. And the discussant is Max Rohrer from Norwegian School of Economics.
So thanks to the organizers for letting me discuss the paper. I really enjoyed it, and thanks for the great presentation. So I guess my first slide is redundant, but so let me shortly put the paper in a nutshell. So the way I view it is there are two hypotheses or arguments. One is, the basic one is that individual analysts overweight local information in their forecasts. It's the first part of the paper, 50% of the tables. And the second one is then taking this to the aggregate. So if you hold the number of analysts fixed, a concentrated analyst coverage leads to a bigger absolute consensus forecast error and vice versa. And so I think that the big pitch is that the wisdom of the crowds is not unconditional. So similar analysts might make similar mistakes, which potentially do not average out. So when I read the paper, I tried to formalize this in a very, I don't want to call it model, but I just wanted to see if I can get both hypothesis arguments out of just writing it down. So the way it's motivated is saying, okay, I have a forecast error, and the forecast error of the individual analyst's eye, that is, in this case, in the geographic region A, consists of some idiosyncratic part and some other part which is constant on this unit, which would be a geographical error here. And then this forecast error is proportional to some kind of difference between an aggregate and a local signal. And the signal that the authors then use, because I think the point is more general, but then the authors use car counts for retailers, because that is a setup where they can disentangle the local information, which the analyst is seeing locally, and what the aggregate is. And then the evidence that they provide is that the individual forecast errors are proportional to this local signal, but also in the paper there's a table that if there is more variation in the local signal, then there is also more variation in the forecast error. What I found very neat is, as was already presented, the fact that there's an attenuation when satellite imagery became public information. And as the author said in the presentation, they have data over a time period where it was not available. So that's great. So the second part is that the concentrated analyst coverage leads to a bigger absolute consensus forecast error. And what the authors argue is that the consensus forecast is correlated with the Herfinel index, which measures this analyst concentration. So if I assume that there are two groups of analysts, let's call them A and B, and they have a weight in the aggregate, the weight A and B, and let's say assume that the errors are opposite, then I could express the forecast error as a function of this idiosyncratic part, not idiosyncratic, this part that is unique to the individual area and the weight. And I can do the same with the Herfinel index down here, and then I can basically show that both those functions are monotonely decreasing if the weight is lower than a half and increasing is above. So even in this simple example, so that the arguments make a lot of sense. So I have 5 major comments, and I'll use this baby model that I have here a little bit later. So my main comment when reading it as a first comment when reading is I was thinking about external validity, maybe not in the strict sense, but the underlying argument is that analysts overweight local information and that car lot counts approximate this local information. So then I started thinking, like, are there other signals of local information where you could as well disentangle what you see locally and what you see on the aggregate? So there are some papers that show that individual investors react to the sentiment or the tone in newspapers about firms within their area. So that would be potentially a different measure or a supporting argument. But then I was also thinking, like, are there other outcomes of overweighting of local information by analysts? So if we all overweight our local information, this will lead to that we disagree, and this also will lead to that we agree to disagree in some sense. And if you think about the models on disagreement, one of the big outcome of them is that they lead to a lot of trading volume. Because if I think I'm positive and you think it's negative, then I'll buy and you sell. So then I was wondering, I mean, given that you have your Freedom of Information Act information that you know the location of sell-side analysts, several of them might transition to buy-side analysts. So maybe you could actually say something about the holding and the trading volume of institutions, like where these buy-side investors work, which would be very cool evidence. And then I have a question regarding the regression specification in the second part being the aggregate part. Again, more concentrated analysts lead to bigger forecast error. So I started wondering if firms that are covered by many and geographically dispersed analysts are different. And the reason why I thought that this might actually be a thought to pursue a bit is that if we compare model 1 in table 7 and model 1 in table 8, where the second one includes firm fixed effects, the magnitudes of the uncovered effects actually goes down. Given that the IV works, this is a question about magnitudes and not a criticism of the findings per se, So in your regression specifications, you control for turnover, book to market, number of analysts and industries. And I would suggest to put in some more controls, and even in the paper you write that geographical dispersion matters for firms in many respects. So for example, Garcia and Nurli show that it matters for the pricing. So firms that are less dispersed have a higher expected returns than the ones that are concentrated. And there are some papers that show that this also matters for managerial decisions. So I would suggest to put some, at least the measure of Garcia and Nurli, but also potentially just size in there, just some stuff that correlates with the idea that the firm per se might be dispersed. It's not that the analysts that they're or concentrated. It's not the just trying to separate it if it's a firm characteristics or analyst characteristic. So you relate your paper to 3 strands of the literature. The first one is expectation formation by analysts, the wisdom of the crowds, and big end alternative data. Like an additional angle, which I find very interesting, is that you actually provide direct evidence for what one could call like a mechanism for sustained disagreement. Again, if I see idiosyncratic local information, I constantly overweight this, we just keep on disagreeing, which I think is very neat, and goes back to my first comment that potentially maybe there's something to do on the buy side. And then this is the last one is more a minor point, but there are 2 papers. I found 2 papers that have survey evidence where analysts kind of agree that they view their local information acquisition superior. Those are a little bit older papers, and they're related to the home bias literature. But in the end, I mean, like, you provide really straight evidence on this, which we know from survey evidence before, but I think that yours is stronger and it shows it on a bigger scale. And this is actually my last major comment. So when reading this the first time, and that was also the reason for making my toy model, is I asked myself, so if I know your finding, can I adjust for that? Can I improve the consensus forecast? So, so in my previous toy model, on the left side here, I would have the consensus forecast, assuming that there are these two groups of analysts, just let's say two MSAs. And what I can show is that this is always bigger or equal than if I just equally weight it. I know that this comes from very simplifying assumptions, and I'm pretty sure that if you make this more general, it doesn't really hold unconditionally for all circumstances. But I'm just wondering, can I adjust, if I adjust the weighting, or maybe another way, can I improve on the consensus forecast, and also on how much? Because I think that this would then also speak more to economic magnitudes. And then, I mean, I guess this is a very, very wide shot. Is there like a incremental information return generating in this adjustment that you do to the bias, to the forecasts? Like, for example, I long a portfolio that is that takes adjustment for the error, and a short one that isn't. So is there value creation in there? So I do have some minor comments. So in your summary statistics, you missed two of the variables that you use in a regression, the forecast error range and the car count range. It would be nice to know. I'm wondering if the absolute forecast error is skewed to the right, because I would assume it is, but I'm not sure. And I'm not suggesting to blow up the summary statistic table, but for this variable, I was just wondering if that's actually the case. The robustness you provide in table 7 and 8, I think it would be very interesting to see this on subsamples, just like on initial analyst count, hard and easy to value, big and small. So you have the graphs, and you showed the graphs in the paper and the presentation. And the same for the exogenous change in the analyst coverage, whether this is stronger for, like, let's say, firms that are covered by 2 MSA than for the ones with 5. I know that there is the observations are reduced in that part, but I think that it was very interesting. I would maybe define the Herfindahl index in the text, given that you weighted on the MSAs. I asked myself when reading it, and again, you speak to this a little bit, do individual analysts learn? I mean, like, the way you have it is that it's stronger for younger analysts, and also you show that when the data becomes available, the aggregate effect goes down. But I think that this offers you, at least, because you have a clear, you can measure the bias clearly over time for analysts. I just thought that it would be really interesting. And then the last two comments in table 9. So what you do there is that you say the effects are more concentrated in some part, and one is like saying, okay, it's more pronounced for retail. Argument being, for retail, it's very easy to see the local information, versus, let's say, for some IT firm, it's very hard to know whether they have like a shock in sales or not. I just found it like, so I agree with this argument that if you interact locally with it, then the signal might be clearer. But I don't think that retail is the only sector that I see cars, for example, stopping in front of the store. Regarding the regulation FD, so you say that the effect is stronger afterwards, and you cite the paper that goes in the direction of, I think in the paper it says that there is less guidance. I was just thinking, okay, there might be also arguments for the opposite. Regulation FD eased the access to non-local information, such as conference calls, and also like more information was moving on ETCA. So I was a little bit, I'm just saying, like, one could make arguments for the opposite direction as well. Very, very minor comment. Maybe one could use percentage or basic points for the forecast error. I find it easier to read if there are less decimals, but that's a personal taste. So thanks for letting me read the paper. It was really, really interesting. It's really great data, and I think it's very convincing on the empirical side.
Thank you very much, Max. I'm going to let Will respond to your discussion.
Well, let me just lobby for Max. That was very positive, and I mean, it's great to hear things like, hey, there's even more things that you can sell your paper as contributing to. That's a great comment to get. I do want to clarify on the car counts. you know, we're not saying that all the analyst information is just going out and literally looking at the car counts. I mean, this could be a whole bunch of different channels by this, how this would work, that, you know, perhaps, you know, the local manager and the analyst kind of run into each other at the country club, or, you know, I just see that the store is doing well and I hear from it from my friends who are also kind of shop at the same location. You know, there's a lot of kind of similar types of, you know, informal information kind of stories that fit with the data. We do look at the MSA level stuff. So it's not just kind of a general Atlantis doing good in the example that I had in there, but it's something specific about the Home Depot in Atlantis doing good. So thank you for getting me to clarify that point. I also like the ideas about kind of looking at the Garcia and Norley kind of measures, and kind of maybe even using those as an interaction to kind of see where this effect is stronger. But overall, a lot of nice, clear suggestions. I think we can implement a lot of them, and we'll do that in the next version of that. So I thank you in advance.